Direct fluorination is not a suitable reaction for the preparation of a fluoroalkane because exothermic reaction takes place, highly reactive nature of fluorine result in extensive rupturing of CC and CH bond. That's why direct fluorination is not favorable. Direct fluorination is not a suitable reaction for the formation of fluoroalkane. So in order to have fluoroalkane, what we do the indirect fluorination either by diluting fluorine with some inert gas like nitrogen or group 18 like argon gas, or we do a halogen exchange reaction like Schwarz reaction in which RX haloalkane, X here maybe chlorine, bromine or iodine we can take with inorganic fluorides like AgF, AsF3, SbF3, Hg2, F2. This result in the formation of fluoroalkane. For example, CH3, CH2, CH2I on reaction with AgF gives a CH3, CH2, F2. Here, iodine is replaced by fluorine. So, this reaction is based on the concept of the electronegativity. A more electronegative element replaces the lesser electronegative element from the reaction mixture. Direct iodination is also not a favorable reaction for the formation of iodoalkane because the rate of reaction is slow and the slow reactions are reversible in nature, which decreases the percentage amount of the product formed because of the reversibility of the reaction. So in order to shift the equilibrium in a forward direction, what we do, we simply add an oxidizing agent. Oxidizing agent convert iodide formed in a reaction to the iodine. So this results in the increase in the concentration of the reactant. So according to the Le Chatelier's principle, if there is an increase in the concentration of the reactant, then a reactant shifts, then the equilibrium shifts in the forward direction, which results in the formation of the required product. So in order to form iodoalkane, what we do, either we add an oxidizing agent, which convert iodide formed in the reaction mixture to the iodide changes into the iodine, and that shift the equilibrium in the forward direction. Or we do a halogen exchange reaction, Finkelstein reaction. Finkelstein reaction is a halogen exchange reaction in which halogen, which is either chlorine or bromine, is replaced by iodine to form iodoalkane. This reaction is based on the concept of nucleophilicity and the solubility of the product formed. So two types of halogen exchange reactions are there. One is the Schwarz reaction, which is used for the preparation of fluoroalkane, in which haloalkanes are treated with inorganic fluoride, result in the formation of a fluoroalkane. This reaction is based on the concept of the electronegativity. Another halogen exchange reaction is a Finkelstein reaction, in which iodoalkane will be formed. In this reaction, we use a reagent NaI in presence of diacetone. So Rx, haloalkane, X here is Cl or Br, reacted with the NaI that result in the formation of iodoalkane. So this reaction is based on the concept of the nucleophilicity of a reactant. Let's practice our question based on photochemical halogenation. A hydrocarbon C5H10 does not react with chlorine in dark, but gives a single monochloro compound C5H9Cl in bright sunlight. Identify the hydrocarbon. Now this compound C5H10, as it doesn't react in the presence of in the absence of light, it means this compound must be alkane because alkanes undergo photochemical reaction under normal condition. Alkanes are inert, or you can say have little affinity or little reactivity, you can say. So C5H10 we have. In this case, as it forms a single monochloride, it means all these 10 hydrogens, they have identical environment. And this kind of behavior is seen either in case of neo compound or in cyclic compounds. But if we look at the formula C5H10 and compare it with the general formula of alkane, which is CnH2n plus 2, then we concluded that if 5 carbons are there, then the total hydrogen should be 12. But here we are having 2 hydrogens shorter. It means neo case is not possible here. Okay. So this compound is cyclic in nature. 5 carbon cyclic is cyclopentane, pentagon. So cyclopentane is the compound which on photochemical halogenation, if you do the chlorination of this compound in presence of sunlight, then a single monochloro-derivative will be formed because all the 10 hydrogens here are identical.